Hello and welcome to the Crystal Group Rugged Advantage Podcast. I'm your host, Karen Hildebrand, and in this wrap session, we're going to delve into the rapidly expanding area of autonomous trucking. And to help shed relevant insight into the critical technology needed to fuel this growing application are two of Crystal Group's technical directors, Micah Snodgrass and Les Arnold. Welcome to both of you.
Thank you, Karen.
Thank you, Karen.
Now, I have to admit, I have a very personal interest in this area as my dad was an independent semi-owner-operator. So the trucking industry has always been an integral part of my life, which makes autonomous trucking even more fascinating to me. So, Micah, can you explain what's driving the increased interest in an application of autonomous trucking?
On the trucking side, we've been facing a multi-year shortage of qualified drivers for over-the-road truckers. There's a shortage in the industry of people who are willing to drive those trucks, and there are loads that just sit waiting for a driver to become available. So what you run into is a need to supplement the drivers that are out there, not replace their jobs. We also see an interest in improving the safety of over-the-road truckers. Safety factors can be increased when you minimize the human factors and the general human error that can come from navigating unpredictable traffic, dealing with weather conditions. Adding in an autonomous element to a truck also increases operational efficiencies. Everybody's familiar with drivers who accelerate quickly. Everybody's familiar with drivers who brake abruptly. Autonomous driving solutions can help mitigate some of that by improving predictability in how the vehicle performs on the road, smoothing out consistent acceleration, speed, braking, and overall increasing the efficiency of the vehicle. This increases the reliability of the truck as well as the fuel efficiency and allows operators to accomplish more with their vehicle.
That's excellent background, Micah. I think that'll really help set the tone for the direction of the rest of the conversation. So with that, Les, specific to the topic of safety, can you talk about how the average driver like you or me should feel safe knowing that we could be next to an autonomous truck as we're driving down the interstate?
That's a great question, Karen. First, I think we should do a quick review of the different levels of autonomy so we kind of understand the landscape. Level 0 or no automation is 100% human operation. I don't think you can find a car on the road today that is at this level anymore because most passenger vehicles have level 1 or driver assistance. This offers technologies such as cruise control, adaptive cruise control, and lane assist. And many of today's newer vehicles are coming out with level 2 or partial automation, which includes self-parking, automatic braking, and even lane changing. In both level 1 and level 2, the driver is still hands-on and responsible for the overall operation of the vehicle. When we get to level 3, or conditional driving automation, this is where the vehicle can accelerate around a slow-moving vehicle. It can monitor its surroundings, change lanes, control the steering, throttle, and braking, and all the driver has to do is pay attention and be ready to take back control when necessary. When we get to level 4, or high driving automation, the human and the machine interaction is greatly reduced. Steering, braking, accelerating, and monitoring the environment are taken out of the driver's hands, as well as changing lanes, signaling, and turning. Level 5, or full driving automation, requires zero human attention. There's really no need for a steering wheel, brakes, or even a gas pedal. The autonomous vehicle controls all driving tasks under all conditions, including the monitoring of the environment and the identification of complex driving conditions like busy pedestrian crossings. So where are autonomous trucks at this scale? They're currently between level 2 and level 3. The vehicle is capable of automated operation, but it still requires the driver to be responsible to respond or intervene if necessary. Current autonomous systems offer comprehensive situational awareness. They combine advanced technologies such as radar, LiDAR, and cameras, which provide massive amounts of sensor data to the brains of the system, which of course is the server. Artificial intelligence, or AI, and machine learning collects, interprets, and prioritizes all the data being collected. It renders full 360-degree real-time images and conditions, including visibility, many times further than the human eye can see, even in the dark or in the rain. Additional safety advantages are the autonomous system has no distractions, like a human driver. Computer isn't concerned with changing what's on the radio, having a conversation, texting, drinking a cup of coffee, and even more important, the computer has no blind spots. It comes down to a partnership or a balance between the driver, who can execute abstract thinking that computers can't fully do yet, and automated systems and sensors which can see and process what the driver can't.
Wow, that's really fascinating when you consider all the different levels and the progressions. But knowing that we're still at that level 2 to 3 level of autonomy, Micah, I'm curious about what's needed to execute the artificial intelligence that is required for that level of situational awareness, navigation, and communication that Les just mentioned. In order to make all that happen and that high level of compute power, there's an often overlooked factor coming from all that power, and it's the amount of heat that's generated. How do you make sure a system like that doesn't overheat?
Les made a very good point where he stated that human brains are very good at abstract thinking and computers are very good at linear problem solving. When you surprise a computer with unknown conditions, it doesn't always respond the way a human would. And to approximate how a human would direct a vehicle in surprising circumstances, when things are unpredictable out on the road, does take an incredible amount of processing power. This amount of power does indeed generate a lot of heat. It generates about the amount of 2 space heaters. We see computer heat loads running in the 1.5 to 2 kilowatt, 2,000 watts. Now, if you put 2 1,000 watt space heaters in the cab of a vehicle next to a human being, that human, the safety operator, is going to get very, very uncomfortable. So moving the heat out of the vehicle somewhere away from the people and away from the technology is a critical piece of the puzzle. And that's one of the aspects that has been driving this market to rugged computing solutions. This market started developing using standard off-the-shelf computers, and very quickly the software developers and the integrators discovered that the systems were not up to handling the shock and vibration of going over North American highways that are not computer friendly. And they also discovered that the technology was cooking itself. Put it in the rear of a vehicle and it would bake itself to death. If you put it up in the cabin of the vehicle with a human, it would overheat the cabin to the point that the human was very uncomfortable and the air conditioning couldn't keep up. So a rugged solution that can handle harsh environments, that can handle elevated temperatures, and that also has the option to move the heat quickly and efficiently away from the computer, away from the human, outside the vehicle to the ambient air, is crucial to keeping these systems operating reliably and comfortably while they're over the road. We've developed several different approaches to solving this thermal issue and allowing high-performance compute components to be in a vehicle without jeopardizing the driver or without sacrificing their own performance or their reliability. So we will take an air-cooled solution or a liquid-cooled solution, marry that together with one of our rugged servers, and ship that off to our customers for deployment into a vehicle.
That's really impressive. And what's important there is really factoring in the different conditions. And I appreciate you comparing it to the same amount of heat as 2 space heaters, because that really puts it into perspective with what both the vehicle and the operator would have to be dealing with and why it is so critically important to be able to transfer that heat away to maximize the operation of the vehicle. So, Les, with thinking about the heat, also relates to the external environmental elements that these vehicles experience. How do you ensure that the onboard AV and AI technology can endure the broad spectrum of unpredictable and varied conditions on the open road?
As Micah mentioned, autonomous systems must withstand a wide variety of conditions, including extremely hot and cold temperatures, varying humidity levels, and, of course, shock and vibrations. Although these aren't military or combat environments like most of our rugged servers exist in, they still experience rough roads, speed bumps, railroad crossings, and the potholes, which over time they add up on a mechanical system. Then we need to account for the environmental conditions. We have special processes that we do to our electronics to protect them from humidity and moisture. But the most important environmental concern is the heat, as Micah mentioned. Most electronic components that we use don't suddenly just die when they overheat. They throttle and perform at a reduced capacity, which is part of the reason the driver is still needed in the vehicle. It's critical that these vehicles stay on the road and collect data, so we need to be able to remove the massive amounts of heat these servers and GPUs generate. As Micah mentioned, the 2 kilowatts of power, they're still human in the cabin. So most of our autonomous partners are using liquid cooling in their systems now with an external radiator that removes the heat from inside the server to outside of the cab. None of the conditions I mentioned can interfere with the critical data processing and decision-making being performed by the autonomous driving software. So Crystal Group's experience in applying mil-spec standards ensures that Crystal Group's RIA and all other rugged computer devices deliver seamless performance under all conditions.
That's an excellent way to summarize the two between both the internal and external conditions, because it's not about one or the other. You've got to really factor in the full environment and the full scope of what's happening. And as you mentioned there at the end, none of it can interfere with the critical data processing that's taking place in order for that system to do what it needs to do for that autonomous environment. So as we wrap up, Micah, I'm curious what you see as the next big hurdle for autonomous trucking.
That's a question that gets asked on a very regular basis. Early on, there was an attempt made to develop a solution that would operate everywhere under all conditions and do everything for everybody. And many companies tried this approach and it just did not catch on. The technology is not ready for that yet. So 2 things are needed right now. The first, there does need to be a density increase in performance density and compute density for the technology that's available. Right now, we're drawing about 2,000 watts worth of power off of the engine, off of the alternator, to be able to power the current solutions. In order for this to go full scale and be a production solution that can be mass deployed, the compute power needs to increase and the power consumption needs to go down. The software also needs to become more efficient. There's a lot of code optimization that needs to be done in order to make this mass deployable for autonomous trucking or even autonomous vehicles. The second thing, and the industry has already started in on this second part, and it's very exciting to see, is that manufacturers and vendors and solution providers are starting to come up with specific solutions. So Crystal is focusing on autonomous trucking. We're focusing on autonomous buses, autonomous construction equipment. So very specific solutions for very specific markets and sectors. And that allows us to divide the big problem up into bite-sized pieces, into manageable technology solutions.
And those are both excellent factors to consider. Back to your point about there is no single solution. And so making sure that as we move this technology forward, whether it is for trucking or cars or construction equipment, that we're really factoring in how the customization of these solutions relates to the specific performance required, as well as the limited footprint and space that they're being required to operate in. So, folks, that brings us to the end of today's wrap session. Les and Micah, thank you for sharing your time and insights with us today. And, of course, thank you to all of our listeners. Remember to subscribe to the Rugged Advantage podcast at crystalrugged.com/podcast and contact me at info@crystalrugged.com if you have any questions about today's conversation or a suggestion for a future wrap session. Until next time, have a great day, and I'll wrap with you soon.